Hello everyone, this will be an introduction to how game engines are built, beginning from installation to code, on using shaders for creating light, shadows, animations, skinning animations, and extra effects for every little need of a simple engine can have. So, not too much talk. Let's dive into practicing. First, we need the development environment. And so let's find the tools we need. We need the initial package named RevoEngine. This package will contain external tools that connect all our step-by-step build of the engine and the external tools that will attach to it. So you can clone or download. This will be your choice. We will need Windows SDK, in my case SDK for Windows 10, so download it. You will need DirectX Software Development Kit, so download it. We're going to use Visual Studio Community Edition 2015. You go on Downloads, All Downloads, click on Visual Studio 2015, and here you can download a web installer or a ISO. After downloading Visual Studio, double click on ISO if you download it. These options are going to be displayed. So Visual C++ for minimum tools and compilers, and we will going to use GitHub, so I'll check this box. Here we're going to showing install button. So press it, wait for a while, and the installation will require about 16 gigs. That's it. When you click launch on Visual Studio, this is going to be the first view of it. So click new project, select C++ Win32 console application. Select the destination folder of your project. And name it. So that's okay. Next, we're going to set up this. We're going to be a DLL, the whole engine that we would want to link to any other project. So you put in there, include folder, and everything should be fine. And export symbols, precompile header, and security development lifecycle, so it would be unchecked. And click finish. So we're going to see a lot of things that Visual Studio created for us. The first is this macro that is defined in here. So this is the default macro that Windows 2 DLL, and this Dusky expert. It's a macro to expand the exportation to external access to these tools. So pretty much everything for the the DLL creation process. So, and we have a DLL main that is the need of the exploitation of this DLL. So we on this project going to use SDL because one of the main features that we want to this soft engine, if I could say that, is that we want to create a game, a simple testing game for the engine, run easily on Windows, and creating a project on Android in Visual Studio you can deploy to that. So SDL is pre-prepared to use the context of windowing, event pooling, and everything like that for Android too, and it's the main use of this SDL. And we have a little bit of workaround to make it more object oriented, because SDL have its own way of doing things, and it's not that much good for object oriented thing, but we try to avoid it. I haven't built any code for this entire engine, but we make it online. We're making it step by step from scratch. Almost scratch. Scratch would be windowing and event pooling from beginning, but we won't want to deal with this. We want to make the interesting thing to be more we want to build things that could be interesting for computer graphics and the whole thing on an engine we're gonna need. So we're going to download the packages that we want and configure to Visual Studio use it. The source and the project itself, because we won't want to set up a RevoEngine configuration. We're going to link the lib, copy and paste things from one folder to another. We want to make the whole thing more automated, more automatized. So let's download it. We're going to lib sdl.org, lib@sdl.org. We're going to download the source code. It's activity development. A couple of days ago we were in 2.0.3 in the same page, so it's a good thing. We're going to use this, and it's really being used. It's really stable thing. I'm going to save it on my desktop just for copying the project and stuff like that. So is that we're going to use image some other projects of the STL, but we're going to download it on demand and learn how to load things, images, mixer for sound, net for network connection, and TTF for font rendering and for creation of the interface on a little bit more reliable and simple. We don't want to deal with this, so we're going to use STL for the most of the stupid work, linking a lot of projects that handle with this, handle with this, handle with this, handle with this. So the STL would be a more simple way of doing it almost from scratch. After if we want to make more options on inside project to expand this for more platforms, more vendors, more even STL is portable, but if we want a specific feature of something and link this, we're going to use a fully and design pattern thing of the build of engine. This is the most hard work part, that think how to organize the code of it. I'm going to write some I'm going to create a class diagram to organize things on demand and code a bunch of classes that makes me work around the non-object oriented thing of the STL. So let's configure it and stop speeching stupid things. Extract. This is the whole project. Here in Revo, we go here, show files. We're going to create a folder. This is the folder hierarchy. So this new folder. I'm going to use this pattern to the usage of external tools. So external, just a folder, and there, where I saved it, I'm going to enter on external, copy the STL with the number, and that's it. So it having here all the .h files that we're going to link and the project to have access to the functions, and here we have the Visual C compiler, the projects that we need to link to the RevoEngine project. Let's check that. here add a new existing project. Going to the location, project, external, as I speak before, as I talked before. So Visual C, and for SDL we need two things. We need SDL, that's the main project, and the SDL main, that is a project main with the source that handle the Windows and Linux workaround the initialization process of the SDL. So for Visual C, use SDL. This is the project, so let's make it here. And existing project, SDL main. This SDL main, and this project here is a little bit outdated, so we click here and upgrade Visual C++ compilers and libraries, and that's okay. This too. And the RevoEngine, and this is a Photo Explorer. I'll remove it, and you know that we need the reference of these two projects to this. We're going to use this as project because we want to link to the RevoEngine in the future for Android build. So we're going to use the source of this and link them as it was done in the Android thing. So I'll reference these two projects, STL and STL min, and the lib of this two that was going to be generated, we're going to be linked to the RevoEngine automatically. So the SDL, we need to reconfigure this project, and click here. So as I said before, we want to just configure once, and all platforms use the same thing, because it's the same thing for the whole project. We don't need to change it. So we're going to output the DLL, project name SDL.dll, going to be the output of this SDL library, and the output directory, we're going to use solution there, solution there, platform/configuration. If you're clicking here and edit, these are macros from the Visual Studio. So if you click in macros, you're going to see a list of it, starting to start typing, and it's going to show what is it. And here is a little evaluator of it. Using macros, we make the project more portable. So if you download it in your computer, you're going to see the relative directory, the project directory. It's going to be the same from here to there, and this is where your the Visual Studio going to handle to you. So here is the output. When we run, we need the DLL to be in the same folder as the .exe, the output of your game, and the RevoEngine will generate a DLL2 to the same folder, and need to be in the same conditions. So this is the solution, platform configuration. So click OK. That's OK. Here we need to link to almost the same thing. So this is going to be the intermediate folder where the Visual Studio compiler generates the object to work with the individual file compilation. And we're going to put in the suit directory to let it handle the whole thing in a separated directory to make we don't worry with a lot of files that it was generated. So intermediate, and that's it. Solution there, platform configuration, intermediate. It's okay. So apply. And here we have the include folder directory, and in other projects we're going to change in future we're going to change this, but this time it's not needed. Linker, it's okay for STL. Press OK. Main, we're going to make the same thing to it. So solution to platform configuration, it's okay, yeah. It's okay now, but just intermediate. Link, it's going to generate the .lit only. This is a static library, so you won't see a DLL file in here. After the reference was made, we going to choose the build dependencies, project dependencies. These two, it's okay. Source. And we need another project that is the testing thing of the RevoEngine. This is where the built game will going to be. And we're going to create a new project, Win32 console application. Should be in the same folder because it's a testing thing. So testing that's okay. So this is going to be a simple console application, empty project, nothing special to this, and that's okay. So here we're going to create our main. The main project, the main of this going to handle the initialization of the RevoEngine, the creation of the things, and testing all the code that we going to write on RevoEngine, and see the windowing, the creation of the objects of the game, and that's it. We start testing the project. It's just a sanity check. Test if the compilation is done correctly. And for this project we need to link these two projects. In the future, when you generate the libraries of these two, the three projects, the library is going to be in the same folder and listed as we need to link to the testing RevoEngine. In the future we can create a generator of the project, so a template project to make this available for this RevoEngine available for anyone to use. So we need to reference the other three projects, view dependencies, or check. And for this project to use RevoEngine, we need to configure the include directory to access the header files of the SEL. So in here we're going to use macros too, but let me add this. And down here you see the evaluation. Project there. This is the RevoEngine project there. So external, the folder that we created. SDL2 2.0.4 / include. This is the director. So we're going to see the evaluation here. That's supposed to be right. So it's okay. Remember to let it be in all configurations so you don't have any problem with the debug to compilation changes to release instead of debug. So let's apply it. And now we should have access to SDL. So here, SDL, yeah, we have access to it. So I'm going to try it out. So init this is just a sanity check of the initialization process. so don't worry about this code, it's just a sanity check. Need to include the general keys. So I'm going to create a new header that we want to add all our kernel headers. That we will need, like IO string and stuff. And the RevoEngine. I'm going to use this in here, but in future we can change it. Common. That's not right. Oh, okay. Common red headers. That's the include. That's not right for the project. So we're going to put RevoEngine properties. We're going to make a include directory in here to put our next created header files. So include going to be its relative, so I'm going to include the include directory related to RevoEngine. And include itself the project here, project there. Okay. This should let us use angle brackets. Yeah, that's okay. This is the testing of the STL initialization. So you don't need to worry, this code is going to be removed. There's common functions that we're going to use on the STL inside wrapper. Here, this is the constructor of the RevoEngine, and that's it. So we need to use this on our testing RevoEngine. So here in main, we need to include the RevoEngine folder. So here we need to go up into the dot up. That's up. So we're going to use here, and that's the include of the RevoEngine, and that should be fine. That's it. So we include it. We should have access to RevoEngine. Yeah. That's okay. RevoEngine. So here we're making the testing of the constructor of RevoEngine. Remember that Visual Studio created with a C in front of the name. That should be okay. I don't think there's going to be a problem. So this is just a testing of linking things. This whole code we're going to be at GitHub, so you can download and do whatever you want. The license of this whole series we're going to be open. GPLs, if I remember, this is good. That's okay. You can use it whatever you want. If this whole thing turning into a good thing for me, I'm going to use in future projects. So that's not a problem to use. This is not the main goals of here. So main, we're going to instantiate the C RevoEngine that was created before. This is the constructor. We are writing this code on constructor to remember you. So it's here when you instantiate. It's okay. It's just like that. Control-Shift-B should build correctly, if I think it's correctly. That's not okay. The RevoEngine wasn't configured to output to the same director. Should be the main. And the whole step problem. I'm going to include the headers in the standard FX. This is a precompiled header that compiles all things that we were linking to this. So it reduces a lot the compilation time, and that should be the main problem. Setting the common headers in here. So let me see, compile. That's it. It's compiling this, and the RevoEngine is not pre-processing the things that we need. So I'm going to add to common headers the SDL2. This is referenced in here, so it compiles and should export correctly now. That's okay, it was built, so the initialization should be fine. Let's execute. Bug. It's not a file. Turn to application. RevoEngine. We are on Win32 testing. SDL2 TLO. RevoEngine. Let me see. We should blame the RevoEngine, not the testing RevoEngine. That this is just a DLL. So let's rescope to this. Play. Yeah, it's trying to start the RevoEngine.dll. It's not a valid program. That's okay. Back. So it's pretty much initializing the thing. And next we're going to set up the glue that is a handler for the OpenGL. This step going to take a little bit more time to complete, so we're going on the glue GL Wrangler library. It's extension for extension and working around the common features, and this does a lot of hard work for us in the context of OpenGL. So I'm going to extract this here. So we're going to copy this to external that is needed. So it's external to glue. It has it on project too. So external, Revo external glue. It's in source lib config autumn build. So we're going to use the last version of it, and we're going to use the DLL generated thing. So let's select glue and update the Visual C++ compilers and libraries. It's okay. We need to reference this and the RevoEngine. It's here, and we need to include the libraries that we need that are in there. So here, RevoEngine external glue include. Here. Projector is not needed in these two cases, but I'm going to use this because I don't want you to rely on things like that, so that's okay. RevoEngine should be fine. So we need to configure the output directory of it. So we're going to set in here. You can see the evaluation. I'm going to change in here. And the same directory as the others. So here, so that's okay. Apply. I'll set the target name for all the configurations to be glue.dll, and the library itself use the OpenGL 32.lib that is in your system. So it should compile. I need to reference the glue here. See the project dependencies, it's okay. Build, Revo and testing. The order is, it's okay. And we need to link this to our project. Reference the glue in our project too. And on the RevoEngine we need to set the input to use OpenGL 32.lib2 because it needs to link to this library. That's okay. So testing engine needs to be linked to it too, so it's okay. Yeah. Let's test the glue stuff. Glue always needs to be included before any GL library. It's here. Glue.h. That was included correctly. We need to include the STL OpenGL that has the OpenGL thing of the libraries, and here in the RevoEngine we're going to make a testing thing. So it's just testing of configuration, so you don't need to worry about that. This is a glue code, so I'm going to use the run thing. This is the STL event to handle the close event of the window we're going to create. So STL pull event, the entries of it, switch event type. So this is the type of the event. So case STL quit. That's event type STL quit. Change the running state to false, and that's okay. That should open a window, and when we open a window, we close the window, and it handles for us in the event. I have a read writing a testing thing, so you don't need to worry about this code. I'm going to show you because I was testing the STL itself. It's just a glue code that I'm going to put in there to initialize the glue. It's know about it, and this is the context creation of the OpenGL. That's it. STL OpenGL demo. I'm going to explain all those features and the context, so you don't need to worry about this. And another glue code is the swap window. clear. So STL swap window. We swap the buffers of the window too. Clear color. Say it's red, a red window. So red. One. Color buffer bit. So this is the testing for a glue initialization. You need this. You need to initialize everything on SDL. You need to create a Windows suitable to a OpenGL context and a SDL context itself. And it's okay. Associated to a window. Pulling events, clear color, clear, swap buffers. That should be okay. Let's try it out. We're going to the folder. The folder we are testing in debug. Enter to debug. That's glue.dll, revo, SDL. It should work right now. And here we are. We have a context window, red as we want. The viewport's not handled and resizing the window because it's a event of the SDL. We need to handle this too, or make it resizable on fixed steps. So it's not our intention right now. When we click close, it's okay, it's running. The whole project is configured to run with the OpenGL thing, and that's it. It should be the first configuration step. The source code we're going to be at GitHub, and the links of the libraries and the whole huge configuration step. Please like the video if you liked it, and wait for the next episodes. The whole series we're going to use the SDL libraries, so it has a lot of glue code to deal with windows and contexts and events. It's the same code always, and we're going to create a window and application initializer to handle this code, to make a C++ more object-oriented code to use on on your personal code, and we're going to use on test on RevoEngine a lot of features that we want to use. A scene, a better way of dealing with events than this. This is not object oriented. This is not a good thing if you want to satirize your game in components. If you want to extend anything, this is not good. I hope you enjoy it, and see you next time.